Okay, because these issues around interior and exterior angles of polygons are quite tricky and they're right at the end of the foundation paper, I want to give you a bit more practice with some questions on these just to make sure you're fully prepared to answer the most difficult questions on the GCSE paper. These are not easy. So here's an example of a GCSE question at a 4 marker from 3 years ago. It tells you that you've got part of a regular octagon. So octagon tells us that it's 8-sided shape, and it wants us to calculate angle CBD. Remember, angle CBD is the angle I turn through going from C to B to D, which is this angle here. That's the angle I'm going to calculate. It's angle X. Okay, so there's a couple of things that we're going to have to do first. Well, the first thing I want to know is about either the interior or the exterior angles in an octagon. Up to you which way you go. I think it's quicker here to do it by looking at the exterior angles, because I know that my exterior angles are going to be 360 divided by 8. So I'm going to draw in an exterior angle here. So let's assume I'm going round anti-clockwise. There I'm going to extend that. There's an exterior angle. Here's an exterior angle, and so on. All of those are exterior angles. So let's find that exterior angle first. So the exterior angle is going to be 360 divided by 8, because it's a regular octagon. Well, 360 divided by 8 is 45 degrees. So I know that this angle here, angle at C, is 45 degrees. Again, this is like those multi-step angle problems from before. If I know that that's 45 degrees, then let's find out what this green angle here is. Well, they're on a straight line, so my green angle, which is angle BCD, from B to C to D, so BCD must be 180 take away 45, because its angle's on a straight line. And that is 135 degrees. So we're almost there. I found that this is 135 degrees. Now I need to find out what X is. Well, here it's really important that we recognise that this triangle is an isosceles triangle. How do I know it's an isosceles triangle? Well, it's a regular octagon. So if it's a regular octagon, it means that this side here and this side here are the same length. Those two are the same length. So I know that X and X over here must be identical. So I can then say that X must equal 180 take away 135 divided by 2, because I'm sharing that equally between these two base angles. 180 take away 135 is 45, divided by 2 is 22.5 degrees. And the reason why is it's an isosceles triangle. Not easy, huh? So that could come up towards the end of the foundation paper, and it even crosses over into the higher paper. Pause the video, write down the worked example, and then I'll give you some questions to try yourselves. Okay, so here are 3 questions for you to try. Try and do as much of this as you can yourself. When you've finished, please press on pause so that you can go through the solutions. For the third question, that point P is the centre of the pentagon, so you know that this triangle here is again an isosceles triangle. Okay, pause the video now. Okay, so for question 1, we know it's a pentagon, so I started by finding the exterior angle. 360 divided by 5 told me the exterior angle was 72. Using angles on a straight line, I found that the interior angle was 108. Then I know that I've got an isosceles triangle here, so I've got 180, take away 180 divided by 2 gave me an answer that X was 36 degrees. Very, very well done if you got that one right. Number 2 was a lot more difficult. So I started by adding in my exterior angles. It's 360 divided by 10, so the exterior angles are 36 degrees. That let me, having found the 36 degrees there, I could find the interior angle here of 144. So the interior angle of that shape was 144 degrees. I've got my isosceles triangle. 180 take away 144 gave me 36. Divided by 2 was 18. So I know that this angle was 18. I've got 18 and 36 here. Together, that would give me 54. Together, these two are vertically opposite angle x, so it must be 54 degrees. Your last one, you've got regular pentagon, so I know that the total interior angle of regular pentagon is 108. This angle in the centre here must be 360 divided by 5, which is 72. So knowing that's 72, each of these must be 54. So 108 take away 54 also gives me 54 degrees. Okay, very, very well done if you managed to do those on your own.